Hey everybody, welcome back. We're going to do another video on this so that we can kind of keep the stream going. We're still talking about math tools. When we started this process, we looked specifically into kind of systems of measurement, and we looked at how the metric system came about during the French Revolution and how that counterpoints to the imperial system, which typically gets used in the United States. We then looked at things like scientific notation and learned how to use that. And then got deeper into kind of the bits and pieces that make the metric system do its job. Today is kind of the shining moment in the metric system and why the metric system can be useful. Not only was it a standardized system, but it's an easy system to move from one unit to the other using these things that are metric prefixes and the fact that everything moves by powers of 10. So today's work is to really kind of say, here's a tool to make conversions from one system to another in an easy way. I call this method the stair-step method. I didn't develop it, but I think it's the easiest one to kind of picture in your head and potentially be able to do this work in your head without worrying about grabbing a calculator and figuring out how that goes, which is why the metric system is important. The last presentation, I showed you this box here that has all this information about those metric prefixes and what they do. Each one of these levels, of course, shows the size of the unit. That's what the metric prefix does. It allows the unit itself to be kind of a larger size or an amount or a smaller amount. And if you want to measure something like a distance, the metric system can do it all with the same unit by just scaling the size of the unit. Where if we're talking about meters, for instance, that would fit right here in the middle where we would call the base unit. But then base units, we can put those prefixes out front of them. Some of them sound very familiar, like the K for kilometer or kilometer, or down here for the little m for millimeter, right? But each one of those scales the unit by a certain amount. And then we can go from one kind of size of unit to another size of unit and talk about kind of equivalent values. And so what I mean by equivalent values is that in the United States, say we had a nice crisp dollar bill. And I said, I'll trade you 4 quarters for that $1 bill. You'd be okay with that because you know that 4 quarters is equal to $1 bill. And there's a easy conversion that you can do in your head because you've been made aware of that for your life. Same kind of idea here is that we could say, well, how many dimes is that? And I could hand you 10 dimes. And 10 dimes is also equivalent to 4 quarters, which is equivalent to $1. All of them have the same value, even though the numbers 1, 4, and 10 are not the same. Nickels are 20 and pennies are 100, right? Each of these amounts are equivalent in value, even though those numbers are not the same. So 1 equals 4 equals 10 equals 20 equals 100. Those are all equal if you put in the correct units to be able to say those equivalent values are there. So $1 equals 4 quarters. I'm adding on the unit to the end of it, and then we can say those things are equivalent. So how do we do this in the metric system using the stair-step method? Well, in the stair-step method, we're going to go ahead and put all of these metric prefixes kind of in a line along a staircase, if you want to think about it. Where on the top of the staircase, in my case here, is the larger sized units. So kilo is a larger prefix than a milli. A kilo is 1,000 of whatever unit that you've got, and a milli in this case is 1/1000th of whatever you've got. So those are kind of the two ends of the spectrum where the unit sits in the middle. When you come about conversion factors, though, is that we can go ahead and move up or down this staircase, and by doing so, we can just move the decimal point to the left if we're moving up the staircase, and we can move the decimal point to the right if we're moving down the staircase. So that makes it pretty easy. Let's take a look at a situation where that's true. So let's start with a particular unit and then move it up and down the staircase and see how that affects kind of what we've got. I'm going to start here with 1,000 millimeters. 1,000 millimeters. So if I start with 1,000 millimeters and I take that up the staircase from the 1,000 millimeters to the center, all I'm going to do is I'm going to move my decimal point. Here it is to the left. Right now I have a decimal point here, just to the right of that 0. I'm going to move it to the left by 1, which means that 1,000 millimeters is the same as 100 centimeters. They are equivalent values. And that's the same as 10 decimeters or 1 meter. So here we go. All of these things are exactly the same value. They measure the same distance, but they have a different unit stuck on the end of it with a prefix in front of the base unit. And we can keep going. So we can say 0.1 decameters or 0.01 hectometers or 0.001 kilometers or kilometers. And then we take a jump where we don't have any more prefixes within here. There's a jump from kilo all the way up to mega, and it goes from kind of this 10 to the third, which is a 1 with 3 zeros after it, all the way up to 10 to the sixth, which is kind of million, if you want to think about it that way. So when we do that, we're going to continue to move the decimal point to the left, but now I have to move it not 1 space to the left, but 3 spaces to the left to get up here to megameters if we're moving our way up. If I wanted to go down here, I could do the same kind of deal. And let's go ahead and figure out how this came about. Now, this amount of 1,000 millimeters is also equal to this number down here. Again, 1, 2, 3, 4, 5, 6. So we've got a million here. And this symbol is a Greek letter that is the Greek letter mu, like a cat, mew, right? So we've got a million micrometers. Right? So keep these things in mind. All right. Well, let's go the opposite direction. If we go down the scale, on the other hand, we can start with a particular unit. Like let's start here with a kilogram. Kilogram is a unit of mass. And if we work our way down, we're going to move our decimal point to the right instead. So move it over to the right 1, and I get 10, and I get hectograms, decagrams, and then we get to the grams straight. So 1 kilogram is equivalent to 1,000 grams. Keep going. 10,000 decigrams, 100,000 centigrams, 1 million milligrams. And then we jump all the way down to micro, which puts us into this camp, which is, again, moving our way forward to the billions, right? Is that right? Thousands, millions, billions. That's amazing, right? Going from kilo all the way down to micro. Now, as we go into it, let's take some practice and figure out what to do with this. So the easiest type of conversion here is to go from some sort of unit that has a prefix on it to what we would call the base unit. So in this case, it's a millisecond. And milliseconds, we can convert those and say, well, if I've got 300 milliseconds, how many seconds is that? And I can walk down my staircase or up my staircase to figure this out. So the first thing you need to figure out as we're thinking about it is how many stairs do I need to move and in what direction am I moving on the staircase? So if I'm going from milli to the base, let's take a peek at the staircase here. Here's milli and here's the base. And so clearly the direction that I'm moving is I'm going to be moving up the staircase. And if I move up the staircase, then I'm going to go ahead and move the decimal point to the left. And so I'm moving up the staircase by moving the decimal point to the left. So let's go and drop that 300 milliseconds in there, right there. And if I'm moving up the staircase, how many stairs do I need to move and how many points or movements do I have to make the decimal move to the left? I have to do that 1 stair, 2 stairs, 3 stairs. So that means that each time I'm going to move the decimal point to the left. So 1 stair, 2 stair, 3 stairs. So my final answer to this is I walk away with 0.3 seconds. So 300 milliseconds is 0.3 seconds or 3/10 of a second. So I moved up the staircase. I counted each one of the stairs. I moved my decimal point to the left 3 slots, and I get my final answer. Pretty easy to do. We can go the opposite direction in the exact same way. So this being the case, I might turn off this little, no, let me see if I can stick me in the corner over here. I have a set of questions here, A, B, C, D, E, F, G, H, I, and J. And what I'd like for you to do is to go ahead and try each one of these on your own. So get out a piece of paper right now, get out a pencil, and I have some resources of the stair-step method. You can either print out if you would like to, or you can write it down, or you can can go back in the slideshow if you want to. By looking at the slideshow itself, I've provided that too. But I'd like you to go ahead and pause here without looking at the next slide and see if you can answer each of these questions. And so I'll wait here for just a moment to give you a chance to pause the video. All right. After you unpause the video, hope you're coming back to this and you've done each of these different problems. Now, really, if you haven't done it yet, pause it and do them. There's no better way to test yourself than to make sure that you can do them yourself. So anyway, let's go and take a look at the answers, assuming that you've done that. And here they are. So 15 kilometers is the same thing as 15,000 meters. And I'm not going to read each one of these, but you can see that each of those is the case. Something important to note is that I have put all of the prefixes in green. And that can be important when we start dealing with different units. Right now, all of our units are in meters, but we don't just measure the dimension of length, we measure other things too, but keep in mind that all of those prefixes are going to go ahead and be in green. On this side, we were going all to the base unit, and on this side, we went to other units, kind of up and down that scale. So let's try some other problems here too. Now we're looking at some different units instead of just meters. I have a kind of a cheat sheet up here at the top. As we learn new things, we'll learn what these units are for and what they do. The first one is this PA, which is 2 letters, and that's pascals, which is a unit of pressure. The second one down here is the F, which is a farad, and a farad is a unit of capacitance. When we get into electricity, we'll talk about that. The uppercase C is a coulomb, even though it has the B on end, it's called a coulomb, and that's a unit of charge. The HZ here is hertz, and so that's a unit of frequency, and the W is watts, which is a unit of power. So I'd like to see if you can make these conversions, and they're all going here to the base unit. So go ahead and pause this, try them out for yourself, and then I'll show you the answers. All right, let's take a look at the answers. So here they are. Once again, I'm not going to read all of them. You can check them for yourself, but 15 kilopascals is 15,000 pascals, and so on. Again, this is micro, mega, milli as we go. All right, let's take a look at the last set of problems and see how you've done. These ones, we're now looking at not just going to the base unit over here, like the last one, we're now going from a prefix of kilo to milli, so kilo to milli, but we're using some new units here. This J, which is a unit, stands for a joule, which is a unit. This thing that looks a little bit like a horseshoe is a Greek letter, the Greek letter omega, but it stands for the ohm, which is a unit of resistance in electricity. This capital V here, it stands for volts or voltage, and that is a unit in electricity. Big capital T in this case does stand for many things, but one of the biggest ones is a Tesla, which is a unit of how strong a magnet is, or its magnetic field strength. And then the last one is the capital letter H, which is a Henry, which stands for inductance or measures inductance, which is another electricity tool that we'll learn about later in the class. All right, so you're going from one side to the other. Pause the video if you haven't done so yet, and go ahead and make your conversions, then we'll check your answers. All right, let's take a look at the answers and we'll call it good. So as we do this, we're talking from kilojoules to millijoules. So 20.3 kilojoules is equal to this. Let's count 1, 2, 3, 4, 5, 6. So 20 million millijoules, right? So, and this number down here, I don't even want to read. So you get the right idea, but there's a lot of zeros after it. This is where scientific notation can come in handy. Anyway, I hope that helped you understand how the stair-step method works. I've got an assignment for you that I'd like you to try online. And so you've got a resource of the stair-steps themselves. You've got this video to work from, and you've got some questions that I'd like you to try out. All right, good luck, and we'll see you in the next one. All right, take care.